of typewriters and PCs. The floor's all yours.
Thank you, Amy. Hello, everybody. My name is Federico Pigozzi, and I hope you can all hear me. And yeah, thanks for coming. It looks like a great crowd. I'm very happy all of you came here. And when I was writing this paper, I had a problem. When white-collar workers transitioned from typewriters to PCs, we were expecting PCs to increase our productivity a lot. But was that true? When I think about this problem, I actually recall what my father used to tell me. Yeah, he used to be a police officer, and he worked for years just in the police station in an office. And when he actually transitioned from a typewriter to PC, he recalls that killing off his productivity. So why should that be? That's because intuitively PCs add a lot of complexity to our everyday work. If you think about that, they introduce instant messaging apps, social networks, games, all sorts of distractions. They also embed a lot of electronics. They need a CPU, a RAM, a disk to function properly. What about? Oh, yeah. They're also very prone to malfunctions. They require expertise to be fixed. They can be a source of frustration. They are subject to malware, stuff like that. What about a very innocent analogical typewriter? They don't have these kind of problems. And in addition to that, they are transparent. They are mechanical. They're not opaque like digital PCs. So in a certain sense, PC have come to be like ghosts in the machine. For most of us, PCs are like supernatural creatures of which we don't understand the inner workings. And sometimes we have to rely on an elite of skilled workers who are the only ones who can comprehend them. In a similar way to what used to happen in ancient societies, used to happen with pagan religions in ancient civilizations. And what we'll talk about today is basically position paper. So I will take inspiration from the literature. I will discuss two different consequences of this sort of ghost in the machine. One is economical and the other is scientific. And then I will draw my own conclusions on how can ALife take on this consequence? How can ALife contribute? How can ALife tame the ghost in the machine? So let's start from the economic aspect of the story. And let's talk about labor productivity. So it turns out, why is labor productivity important? The amount of output the worker can produce per unit of time. That is important because that's what drives economic growth, and that has historically been true, and that labor productivity has historically been on the rise since the Industrial Revolution. And why? Because intuitively, Industrial Revolution created all sorts of new tools and techniques, like I don't know, the steam engine, new modes of transportation to increase the output per worker. But is that still true? And if we look, so these are plot from the Federal Reserve, and plots the percentage increase in labor productivity starting from 1949 until the 2010s, measured as real GDP produced per worker over total number of hours worked. And of course, there is a cyclical pattern which is due to the ups and downs of the economy. But if you look at the trend, it is actually decreasing. And that's a fact that has been puzzling economists over the last decades. We were expecting information technology, we were expecting computers to increase labor productivity, but that's not happening. And it's an ongoing debate. Why is that happening? It's an ongoing debate in the economic literature, and some economists actually agree that may be because computers, maybe they decrease our productivity because of the reasons I said before. Also, technological unemployment. Okay, we're all familiar with that. It's a politically charged topic. I'm not going into the detail here. There is a consensus, generally speaking, among labor economists, there is a consensus that in the short term, technology tends to increase unemployment, but in the long term, it can actually favor employment. We know that, but we're not talking about the problem per se. What we are interested in is that a debate actually exists. And there is I mean, there is a consensus among social scientists that the increase in automation, especially in the introduction of artificial intelligence, is actually creating a paranoia, a hysteria among the general public. So then the question becomes, what can ALife do to mitigate these issues? And my humble suggestion is that ALife should focus on technologies that are minimally intrusive and fill new niches. Why minimally intrusive? Because we want technologies that don't interfere with labor productivity, but at the same time want them to occupy new economic niches. We want them to don't steal, in a certain sense, jobs from people. And I will make some examples. Okay, the first one is, okay, you all know of them, the Xenobots. I'm not officially associated with the Xenobots project. So what are they? You know, they are artificially designed organisms. You have an evolutionary algorithm searching in the space of morphologies, of voxel-based morphologies. And the best ones of these are then assembled into synthetic organisms. And why are they interesting? Because they can potentially achieve feats that are unfeasible for humans. For example, navigating the vessels of the human body to tackle cancer cells, for example. That's an example. I mean, it's intrusive. I mean, in a certain sense, it's intrusive. It is not, in the sense it doesn't really get into our way, doesn't really interfere with our work. But at the same time, it can potentially be an economic niche. It can potentially be an occupation that has nothing to do with what humans do. That's something unbelievable that none of us could ever do, traveling the vessels of the human body. And that's as far as and that's okay. But maybe the future may also have bacterial colonies. Now, if you've seen the keynote from Pamela Lyon, she actually argues that bacterial colonies have the same level of cognition that we humans have. And you can actually prove that bacterial colonies, or maybe also slime molds, other forms of let's say primitive, but they're not really primitive forms of life, can solve complex tasks like navigating a maze, for example. What if we were able to tame them? We were able to AI design them to accomplish tasks that are minimally intrusive for humans, but are also unbelievable for them. And that's as far as the economic aspect is concerned. What about the scientific aspect? So if we look at the history of artificial intelligence research, we actually notice a striking misalignment between the theory and practice. We are all aware of this. So on one side, the practice has been able to achieve superhuman performance on many tasks. On the other side, the theory has been lagging behind. Let's make an example. I mean, we're familiar with transformers architectures. Okay, so this is the plot of the number of parameters in terms of millions for the most recent transformers architectures over the years. And we have shifted from 100,000 to more than 1 billion. And that's basic, and that's an advancement. It basically boils down to tweaking architectures and creating these amalgams of entangled layers, parameters, activations, functions, of which we don't know anything. Basically, we can't interpret them. And on the other side, theory, we can't even explain why larger neural network architectures can generally lead to better performance. There is no consensus on that. And so several prominent figures in the field have actually compared artificial intelligence now, especially deep learning, to medieval alchemy, because we have some practical understanding of it. We know how to mix some components to get some desired result, but we don't know what are its scientific underpinnings. We cannot grasp them. And interestingly, this actually is linked to a distinction in the theory of cognition in biology. So 99% of current artificial intelligence research is linked to the so-called advanced cognition field. So by advanced cognition, we mean anything that is based on the nervous system, anything that is neural. On the other side, if we look at the biological literature, it turns out that there is a nascent field focused on basal cognition. That is any form of pre-neural cognition, any organism that can interact with its environment, perceive stimuli, and adapt to its environment without the need of the nervous system is said to display basal cognition. And Mike Levin has been pioneering this field. But we don't see many examples. We don't see many applications. We don't see many applications, examples of these in artificial intelligence research. There used to be. If we look at ALife, it actually turns out that like 10 or 20 years ago, there was some interest in, for example, topics like morphological computation. This computation performed by means of bodies only and not the brain. A relevant example are passive workers. Okay, robots can locomote themselves just by means of their mechanical interactions of their body parts. Also, the example on the right is a research. Okay, there was also a niche field in ALife, which was minimally cognitive behavior. I'm showing an example research from Randall Beer and others. So basically, minimally cognitive cognition is interested in what is the most basic forms of behavior that can be considered as a form of cognition. And so it's mostly aneural. Let's say it's mostly detached from the complexity of neural networks. But those are examples of research. Those were very interesting research lines were popular in artificial life, but later they withered, probably because they withered in face of research on deep learning in the transformers and stuff like that. So then my second humble suggestion is, what can ALife do to tackle this scientific challenge? ALife should turn its back to neurons, turn its back to neural networks, and embrace minimal cognition. And why? Because they can give us potentially agents that act by means of transparent mechanical interactions, transparent mechanics rather than opaque neural networks. So in a certain sense, we want agents that are more similar to typewriters rather than PCs. And so that's the end of my presentation, and I thank you so much for your attention.